Good morning, good afternoon, everyone, and welcome to this session of our webinar series. Today's topic is scaling up the CCS market to deliver net zero emissions. My name is Galoran Turan, and I'm the General Manager of Advocacy and Communications at the Global CCS Institute. For those of you who may not be very familiar with us, we are an international think tank, and our mission is to accelerate the deployment of carbon capture and storage as a vital climate mitigation technology. Our headquarters are in Melbourne, Australia, and we have presence in 5 other countries, including Japan, China, Belgium, the UK, and the US. Today, before we start our discussion, I would like to say a few words of housekeeping. I'm sure before the lockdown period is over, we'll all be very familiar with all the various different online platforms, but for those of you who are not familiar with the one that we're using, you will see that there is a banner at the top of the panel, and on the left there's a button that says everyone. So if you click everyone, you'll be able to see myself and my colleagues, the presenters of today's webinar, Angus and Alex, all at the same time, as well as the slides. Then, at the conclusion of the webinar, Alex and Angus will have an opportunity to respond to questions. Indeed, we encourage you to pose your questions throughout the webinar, and you can do that by typing your questions in the control GoToWebinars control panel that you can see that is sort of shown on this slide. Today, I'm very pleased to be joined by the authors of our recently released report that has the same name as today's webinar, Mr. Alex Townsend and Mr. Angus Gillespie. Alex is our senior consultant for economics, and before joining the Institute, Alex spent almost close to a decade, 10 years with the UK government. Angus is our European Affairs Manager, and he's had a long career in the energy industry before joining the Institute, and most recently as Shell's Vice President of CO2. So Angus and Alex, thank you for joining us today. We thought that we would do things a little bit differently today in terms of this webinar, and we would start with the conclusions of the report and work backwards. So I have the pleasure and the honor of introducing the magic number. The scale of the CCS market, where does it need to be? Indeed, that magic number is 2,000. We need 2,000 facilities, CCS facilities, by 2050 in order to meet the IPCC report's 1.5 target. And indeed, the 2,000 is a number that is consistent with various studies, including IEA's Sustainable Development Scenario. 2,000 facilities by 2050 means we need to have a build rate of 70 to 100 facilities per year. It also means that in the year 2000, we will need to have some 200,000 kilometers of pipelines, as shown on the slide, and some 400 storage facilities. So during the webinar, Angus and Alex will discuss whether this is doable. Is this build rate achievable? Has it been done in other industries? And if it can be done, what needs to happen to ensure that we get to 2,000 facilities over the course of the next 20 to 30 years? And with that, I would like to turn over to Angus to explain how we're going to do this in the course of this webinar, and leave it to you to lead the conversation. Angus.
So thanks, Galoran, and thanks for the introduction, including the photograph of what my hair looked like pre-lockdown days, nice and neat compared to what I'm sporting today. Anyway, in terms of CCS facilities, as Galoran said, we're going to take a slightly novel approach today. The report that Alex and I were involved in, what it looks at is the current characteristics of the CCS project pipeline, or the project development phasing. And what we did in that report, we'll do in this webcast, is look at some of the characteristics of the pipeline and what that means in terms of insights, implications, and learnings for that magic number of 2,000 plus CCS projects by 2050. And probably because it's a dynamic approach, it's really what does it mean for that flow rate, run rate of 70 to 100 facilities or projects a year. So really, when you think of a project development process, what we're going to be talking about here are three separate things if we want to mitigate the risk that we don't achieve that number, or ideally accelerate the number of projects coming through. So those three things are, first thing, the feed rate. We need to see a healthy number of projects entering into project development each year. Second thing is the progress rate. So it's considering how long does it generally take from identification through to operation for these projects we see today. And the third thing is the survival rate. So for every 10 projects that enter the funnel, how many make it through to operation? So with those three things, that's really going to be the structure of what we're going to talk about today. The feed rate, the progress rate, and the survival rate. And throughout, what we'll be relying on is real data that we followed as the Institute, and you can read and report after this webcast. So let's start by looking at the feed rate.
Great, thanks Angus. So the starting point with regards to understanding the feed rate is understanding the current pipeline of CCS projects. And that's what we have summarised in this slide here. So as of the end of 2019, there were 51 large-scale CCS facilities in various stages of development and deployment. So of those, 19 were in operation, 4 were in construction, 10 were in advanced development with a dedicated front-end engineering design approach, and 18 were in early development. And by large scale, what we mean is any CCS facility that captures more than 400,000 tonnes of CO2 per year, or in the case of a facility at a coal-fired power plant, one that captures at least 800,000 tonnes of CO2 per year. And in addition to these large-scale CCS facilities, we also have several pilot and demonstration projects, so 39 in total, and 9 test centres globally. Geographically, as you can see here, most of the projects in operation are in North America, and particularly in the US, where a combination of industry know-how, revenue from enhanced oil recovery, supportive CCS policy and established CCS legislation and regulation have enabled those projects to make it through to operation. And then outside of the US, we have countries like the UK, the Netherlands, and China and Australia, who all have multiple projects in stage of development currently. And Angus, perhaps you could talk us through how that pipeline looks based on other characteristics.
Will do, Alex. So what's not shown on the slide here are some of the industrial activities that characterise the projects you see that are summarised in the chart. So in terms of those 19 operating facilities, what we tend to find, no great surprise, the great majority are in the lower cost industrial activities. So for example, 10 of those 19 are in gas processing work, 2 in fertiliser production and 1's in ethanol. And these are activities that we've found tend to have capture costs around about $25 a tonne of CO2 captured. So these are, if you think about a classic kind of CCS supply chart, these are the activities closest to the origin, so no surprise there. In terms of the same 19 operating facilities, all of them use pipelines for transport. And it may surprise some, but it's worth highlighting as 14 of the 19 use the captured CO2 for enhanced oil recovery or EOR work. So the storage, the pure storage cases are in relative terms a minority at present, 5 of the 19. Now, I think the good news here is when we actually look at the front end of the pipeline, what we find is characteristics that are tending to challenge those biases I've just spoken about. So we're seeing a far broader range of activities coming in. We're seeing cement manufacture, waste to energy, paper, chemicals, far more than just the classic predictable activities that we see in the operating facilities. In terms of transport, some real novelty coming in there as well. So rather than just pipelines, some projects at the front end are considering ships and even barges. And I know that in terms of projects that are bubbling under, they haven't even entered the funnel yet, so they're not covered in the numbers. seen some novel ideas around rail transport, road transport, the whole thing. So I think these types of trends where you've seen a broadening of activities is very healthy when you're looking to maximise the feed rate into the project development work.
And in terms of, I guess, how that feed rate could grow in the future, the other angle we looked at within the report was where those new projects might be geographically. So as well as looking at the current pipeline, looking at the entry of projects to understand that overall feed rate. And looking at it geographically, one of the things that we've, as the Institute, have highlighted in the past is the importance of having supportive CCS policy frameworks in place, established CCS legal and regulatory frameworks, and the availability of storage. And these are the things which will determine whether the greatest near-term opportunities are for CCS. And at the Institute, we monitor developments in these through our indicators, so our storage, our legal and regulatory, and our policy indicators, and we summarise that in our CCS readiness index, which gives a relative score for over 50 countries based on over 70 criteria around the enabling environment that they provide for new CCS projects. And it's perhaps not surprising to know that when we look at the highest scoring countries on the readiness index, they are also the countries where we see the most projects being deployed today. So of the 5 highest scoring countries under the readiness index, they account for 70% of all of the projects in the pipeline today. So they are the US, Australia, Canada, the UK, and Norway. And within those countries, for example, in the US, we see with the expansion of the 45Q tax credits and the recent changes to the low carbon fuel standard in California, there's a very strong incentive there for CCS projects in the near future. So we expect to see more projects coming into this the pipeline that we're showing on the slide here in the next year or so. And then in Europe, and also Australia, Canada, and also the US for that matter, we're seeing greater interest in hubs and clusters supported through public-private partnerships. And they again provide a good opportunity for more projects to come into the pipeline by giving a kind of central transport storage network that they can connect into quickly. So hopefully over the next year, we'll see more projects being added to the pipeline that we've shown here. So the next part we looked at in the report is the progress rate, and I'll hand over to Angus to talk through that.
Yeah, so what we've shown here in the chart, you can see 3 versions of effectively the same thing. It's the overall project pipeline. So what are the development phases? Not just CCS projects go through, but any major capital project. I mean, organisations have their own terminology, their own processes, but generally you'll find this is the type of flow you see from identification through to actual operation. Now again, it's a reflection of the quality of the Institute's data. What we found was that the average time to go through the whole pipeline for CCS projects over the past 10 years or so has been 6 to 8 years. So to go effectively from entering identification through to operation, it's 6 to 8 years. Now the implications of that are quite sobering. What that means is those 51 projects that Alex mentioned at the start, that is effectively what this pipeline will produce through to 2026 or 2028. Now we all rely on the 2030 interim checkpoint when we think of 2050 aspirations. So it's quite sobering to think that we really need to see a boost to what's currently implied by the pipeline if we're going to achieve that 70 to 100 projects a year, that we need to be in call of the 2,000 plus CCS projects that we want to see. Now, Alex mentioned the 45Q tax credit scheme in the US. Very, very hopeful that that's going to really help boost the number of projects coming in. The signs of that, early signs, are very positive. But one of the conditions, the current conditions for the 45Q tax credit, is that any applicant needs to show they will enter the construction phase by 2024. So we found that typically projects take 2 to 3 years to go through that construction phase. So again, the more 45Q can get in with that type of timeline, the more likely those projects will make it through by 2030. I should say as well, incidentally, that 2024 construction start requirement is subject to a current House of Representatives bill, so it may be relaxed in future. So let's turn now to the survival rate. And Alex, if I can ask you to open on that.
Yeah, sure. Thanks, Angus. So we talked through the feed rate in terms of entry into the pipeline. We talked through progress through that pipeline. The final aspect we look at in the report is, as Angus said, the survival rate. So of those projects that enter the pipeline, how many remain in it and reach operation? And this chart here summarizes the survival rate for the CCS facility pipeline between 2010 and 2019. So on the left-hand side, we have the pipeline as of the end of 2010. So at that point, we had 7 large-scale CCS facilities in operation, 4 in construction, and 67 under development. Since then, there are a further 51 projects that were announced. And then on the right-hand side, you can see the pipeline as of today. So as we mentioned earlier, 19 in operation, 4 in construction, and 28 under development. And you can see here there's been a relatively large flow of projects from the development phases to being scheduled, so 77 in total. And so when we looked at the total numbers, what you find is that of the 4 projects under construction and 67 under development in 2010, and the 51 announced since then, only 37% remain in the pipeline today. Now that's clearly something we wouldn't have wanted to be aiming for at the start of the decade, but it does hide a more positive and improving story when you look at it in a bit more detail. And so when we looked at just the 51 projects that have been announced since 2011, what we found that for those, there is a much higher survival rate. So the rate's around 50 to 60%. And you can kind of see that from this chart in terms of the relative proportions of the projects flowing to still remaining in the pipeline versus those being shelved. And then the other aspect as well is that what you see is that as the projects move through the development phases, the survival rate improves. And in particular, once they reach the construction stage of development, then the survival rate remains relatively robust. And so that really emphasizes the need to really help those projects through that early stage of development to reach that level. And then the other angle we looked at was how that compares to other technologies. What we're showing here is just the absolute figures, so it helps to look at it relative to other technologies.
Yeah, so let me pick up there, Alex. So that 37% survival rate that you had mentioned, the one that's consistent with the chart you see here, the timeline you see in the chart, we thought it was good to contextualize that a bit. So we looked for analogues, we looked for parallels in terms of capital projects. Of course, you can challenge anything that we would find, but we thought a fairly good basis for comparison is the experience of LNG, liquefied natural gas liquefaction plants. So over the same period, we did quite a bit of analysis to look at the experience of LNG as capital projects over the same period. And the rate we found for LNG liquefaction plants was 56%. So that compares to the 37% that Alex mentioned. And again, if we slip the timeline slightly, so if we start at 2012 for LNG, what we found is the survival rate actually dropped slightly, albeit to do with gas market trends, we know that, but the survival rate dropped to 44%. But the key thing is the 37% for CCS, it looks relatively healthy compared to the experience of LNG, so it's not unique. But on a more positive basis, I think, it shows that there are still learnings for us in the CCS community, maybe by reaching out to other capital project developers such as in LNG and try to improve that survival rate to get north of 37%.
I suppose one of the other things to mention is in the report we also looked at offshore wind as an analog. Of course, compared to LNG, it's not as analogous for CCS. And there you see much higher survival rates of around 90% in the case of the UK. And so again, perhaps that's provides an example of the types of survival rates you might need to BC or that could be achieved in the CCS market in the long term. And the importance of that really is that you need to develop that healthy pipeline of projects in order to achieve that 2,000 facilities number that Laura mentioned at the start of the presentation.
Thank you. And in fact, I was going to ask both of you, if possible, to go back to that sort of what I call the magic number, 2,000 facilities in the beginning. And thank you for walking us through some of the key determinants of how projects go through the pipeline. Is that number really doable, do you think?
Well, maybe I'll kick off. I mean, you have to remain optimistic if you work in CCS circles, there's no doubt about it. But you can't get away from the fact, when you look at the numbers, it's a massive challenge. It is a massive challenge. But again, in the report, we mentioned some of the other areas we look for evidence it can be done. We might come to in Q&A, go on, we have the data available, but in terms of the number of facilities needing developed, that scale of pipelines you showed, that type of run rate in general, the energy industry has stepped up to the challenge in several occasions in the past. So if CO2 regulation is going to bite the way we predict, and if the entire industry, not just a few competitors, are going to take up this type of scaling up challenge, I remain optimistic it can be done. So it's not easy, it's not immediately foreseeable, but I think the more we can have discussions like this today and understand the challenge from various angles, I think it can be done. It has to be done, you must face it. But the longer we delay, the kind of longer it takes to get ourselves going, the challenge will just get steeper. So we need to start today.
And one of the things we do in the report, Lauren, is highlight some of those sort of near-term practical steps that can be taken to help us on that pathway. So we cover three main themes in the conclusion of the report, which are, firstly, we need to maximize the feed rate of projects entering the pipeline. For that, we need supportive policy for CCS. There's also opportunities in terms of developing transport and storage infrastructure that other capture facilities can connect into quickly. We need to increase the speed of progress through the pipeline to reduce the lead times. For that, we need projects that we can learn from, help to bring down the development cycle, the time it takes to develop projects and the construction time. Again, transport and storage infrastructure can help there by allowing capture facilities to connect into the infrastructure more quickly. And then we also need to minimize the number of projects exiting the pipeline. And so there may be opportunities to improve the learnings across projects, both in terms of success and failures, opportunities in terms of generating more support amongst the financing community for CCS. And then, of course, the importance of having policy certainty so that investors have that certainty to invest in CCS. And with those sort of three themes, that should hopefully put us on a more stable footing to reaching that magic number you mentioned at the start of the presentation.
Thank you both. That's been very helpful. And with that, I would like to start opening up for questions. In fact, questions have been pouring since the first slide. And I've been trying to sort of, in my notes, categorize them under several buckets. So the first set of questions are around capacity. Several people have asked, what do you mean by large scale? And more specifically, when you talk about 2,000 facilities by 2050, what is the capacity of these projects that you are referring to? So perhaps what's the sort of global captured and stored kind of capacity they're looking at by 2050? And what do you mean by large scale projects?
So perhaps I'll start, Angus, and you can follow on. So in terms of the definition, I think I mentioned in the presentation that when we say large scale, we mean a project that has a capture capacity of at least 400,000 tons of CO2 per year, And then in the case of one associated with a coal-fired power plant, it's 800,000 tonnes of CO2 per year. So that's at the individual level what we classify as a large-scale CCS project. And then in terms of the 2050 numbers, so the IEA Sustainable Development Scenario, which is the scenario which we often use in our projections, suggests there needs to be around 2.8 gigatons of CO2 captured and stored each year by 2050. So just as a rule of thumb, if you were to say that the average capture facility has a capture capacity of, say, around 1 million tonnes of CO2 per annum, then you're looking at more than 2,000 facilities that are going to be needed by 2050. And of course, there's a lot of variation between capture facilities. So you have some at the small scale, sort of like CCS with ethanol production. And then at the upper end, you might have CCS with power plants, which have a much higher capture capacity. So it will vary, but I mean, these are kind of rules of thumb, indicative numbers to help give an idea of the sort of orders of magnitude that we need to be reaching in order to remain on track to those long-term climate targets. Thank you.
And if I could follow up, sorry, Angus, I think you were going to add something.
No, I couldn't possibly challenge Alex's knowledge. It's perfect. Okay. The only thing I was going to, the one thing I was going to add, Lauren, is I think we can't lose sight of the fact ultimately it's a volumetric challenge. It's about the gigatons of CO2 avoided. It's not necessarily about the number of projects. But I think these measures that make that more grounded, more practical, more pragmatic, converting into the number of projects helps. But we just can't lose sight of that 2.8 gigatons that Alex referred to.
And the big challenge and the opportunity, kind of, I kind of tend to view them as both, you know, it's two opposite sides of the same coin, opportunity and the challenge, scaling up that needs. So thank you both. And a follow-up question in terms of the number of facilities, but is do you envision direct air capture and BECCS being a part of these 2,000 facilities? I think I might guess the answer, but I will ask it to you, experts.
Alex, you're the analysis man. so yes. I mean, particularly, certainly, as part of the report, we looked at the results of the integrated assessment models that we used for the IPCC 1.5 report. Mm-hmm. And particularly there, you see a major role for BECCS in terms of reaching those targets. So of course it varies by scenario. So I mean, really we need all of these solutions to be taken forward. And you know, there's of course differences in the cost of doing each of the different types of technologies, but it will need a combination of CCS in lots of different applications in order to meet those long-term targets. Yeah, and I think it goes to one of the themes I mentioned during the presentation, is I think the broader the characteristics of the underlying activities, the more healthy the pipeline is, the better chance we have of hitting that necessary run rate. So, I mean, it'd be fantastic. The more we can see BECCS, DAC coming through, I just think the greater the likelihood is of us hitting that magic number of 2,000 plus.
Thank you. Again, a number of questions, quite a few number of questions about those projects, basically the attrition, those projects which have been shelved. So can you talk a little bit about, you know, whether there are sectors and countries, you know, what are the common sort of characteristics of those projects that exited the pipeline? Particularly, it's been noted one was kind of under construction, so why was it abandoned? Or, and also, I think there's a question around what are the lessons learned for the industry from this?
Yeah, maybe I'll start this time, Alex, because it's one of the things I just found astounding when you actually look at the detailed data, the disaggregated data. So what we did was over that same period, in terms of the attrition cases rather than survival cases, looked at trends, and some of the trends are just astonishing. So of the projects that didn't make it through the pipeline, 3/4 of them were originally applied to power generation projects. I think it was 73 or 74% of the projects that fell out were originally power projects. So I think that's just stunning. Other things, if I remember correctly, 3 countries accounted for 3/4 of the projects that failed. The US, which was about half of the total, and then the UK and China. So again, very concentrated, which always helps us when we look for those learnings or the insights that come from it. And then the other thing that struck me was there were, I think it was 3 peak years, 2012, 2013, 2014, when the number that fell out was just extraordinary. Now, in terms of what does it mean, I think it probably reflects more the underlying market conditions than it does anything about CCS projects. So when you think of that period, that's really when gas became competitive against coal in terms of generation. So what I postulate was happening was that a lot of these projects were probably originally on coal. And then when gas-based generation started to become more competitive, it's just the case that the economics got more challenging. Now, as I remember from my painful time in industry on CCS, 2015 was also the year that the UK competition was cancelled at a late moment. So I think there is a question about how committed the policy conditions were around that time. So I think maybe the policy support mechanisms were questionable around then too. So I think in terms of the geography, in terms of the activities, and in terms of the period, there are some key learnings we can use for this if we're looking to, as we say, improve the survival rate as we go forward. Alex, anything you would add?
And in fact, you mentioned, sorry, I was just going to say, a number of questions have been pouring about policy. The most recent, can you discuss how government policy, I'm just reading, should change or be tailored to the feed, progress, survival, succession? Are there particular policy approaches in each that you think are optimal? So that I think leads really nicely, because as I said, a number of kind of questions, you know, about policy, about how these projects can be more easily financed, etc., are kind of coming through. So perhaps you could address, if you could address that, Alex.
Yeah, so I was just going to build on Angus's answer as well, just to say, I think the sectoral perspective is really interesting. When you look at the breakdown, so as Angus said, heavily weighted towards power generation in terms of the attrition. When you look at some of the things like natural gas processing and the lower cost applications, you see there weren't that many projects that have been shelved in that sector, which I guess hints to just the importance of sort of strong business case for the project. You know, we tend to see that those projects can go forward on a relatively low carbon value, and so they've tended to be a bit more robust in terms of that survival rate. In terms of policy, so I guess, so we recently, or not so recently now, we published a report looking at policy priorities for the large-scale deployment of CCS, and within that we highlighted sort of 3 key areas where we felt that policymakers should be focusing their efforts. And so the first being an obvious one in terms of CO2 regulations, so placing a value on CO2 emissions, and we expect that with sort of tightening climate emissions reduction targets over time, that you would see an improvement in that, and therefore that providing the incentive for the capture of CO2. The other angle was the transport and storage network, so facilitating the development of those. And as we mentioned in this report, that can be really powerful for both helping more projects enter the pipeline, and also allowing projects to more quickly move through that pipeline. And then the third area we flagged in that report was around financing. And I think when we talk about the survival rates, in this report we were talking about the importance of having that finance available, and throughout the project having that in place such that it can ensure that those projects remain in the pipeline and reach operation. So I guess they're kind of high-level areas that perhaps policymakers could be focusing. Angus, I don't know if you had anything else to add, given your experience in this area.
No, I think everything just supports it. The value I see of this approach is it just helps policymakers maybe think in a novel way, or to look at potential indicators of health rather than just wait to see what the actual deployment rate ultimately is each year. I think there could be as well some insights for industrial partners from this. So rather than policy conditions, if you turn it around, you think, well, what does it mean for industry? What does it mean for actual project developers? There is something about, so how do you accelerate the rate of feed into project development? So it could be, the encouragement is for organisations to more actively look for CCS options. You know, not to consider them as projects until the market conditions are there or until the CO2 regulatory conditions are there, but have projects more trigger ready to get into the process. And then, like you said, Alex, I think the finance sector can contribute here. Again, it's only speculation, but there will no doubt be cases where the survival rate is tied to the ability to raise finance or to find cover for some of the liabilities and insurance issues we often hear of. So I think there's a kind of self-help angle to this as well in terms of what industry, other sectors can do to make sure we do have that very healthy feed rate, progress rate and survival rate to see more CCS projects come through.
Thank you both, and in fact, thank you, Angus. There are a number of questions about what can the private sector do, what can companies do in order to progress projects faster through the pipeline, etc., which you've just answered. There's an interesting question about the supply chain, and I'm reading, how can equipment suppliers and/or technology providers add value to future projects? Is it all commoditized?
Yeah. What was the last sentence? I just missed the last part. Is
it all commoditized?
I don't think it's at that state yet. I think, I mean, in terms of supply chain issues, I think, I mean, we all see the need to really nurture a kind of robust supply chain, an expansive, experienced supply chain that's ready to go. I mean, I recall from experience that after some major projects dropped the past 5 or 10 years, there's always a question about how committed, particularly the policymakers, are to this technology. So you always felt that the kind of companies committed to the supply chain, it was still a bit fragile. So there is something about just underpinning the solidity, the confidence in the actual technology, continuing to do that. And I suppose the best way of engendering that level of confidence in industry is by results. So the more projects we see surviving, the more kind of projects we see coming out the other end, the more it should build confidence in some of the absolutely critical service companies, technology companies to do that. And one of the benefits of having a technology that in relative terms is still quite young is there's a lot of scope for cost reductions. So for technology providers that are attracted by really making a difference to the underlying solution, I mean, it's ripe. It's just ripe for harvesting those types of reductions as we go forward. I realise that's not really a direct answer to it, but I've given you time, Alex, to think up the knockout response.
I don't have anything more to add, Angus. I think you've covered it well there.
No, but the supply chain in general, it's a huge issue, huge issue.
Well, thank you very much both, and there are a number of other questions coming in, but I'm also cognizant of the time and the time that we allocated for this webinar. So I'd like to thank all our attendees for their questions. And with that, I would, before closing this webinar, I would like to make a few closing points. Firstly, the report that you heard about scaling up the CCS market is available to download from our website under the resources section. And so is our global status report 2019, which is basically contains anything and everything we'd like to think that you would like to know about CCS. So both of these reports are available to everyone, and they are free to download. Finally, we're continuing our program of webinars we call the CCS Talks. The next one is on the 13th of May, and it's the value of carbon capture and storage. It's a launch, that's the launch event for our new report as well, on the value of carbon capture and storage to the economies and to the society. And then on the 19th of May, we're having a fireside chat with DG Climate Director Arthur Metzger on the EU Green Deal and how CCS fits into it. You can follow us. We encourage you to follow us on social media. And if you have any further questions, recommendations about the webinars, about the Institute, or more specifically about our memberships and our consultancy services, please, you can write to us on these email addresses that you can see on the screen on the slide. And we very much thank you for joining us today, and we'll look forward to seeing you virtually or hearing from you in our upcoming webinars. Hope you have a good weekend, everyone, and thank you.
Thank you.
Thank you.